slowly changing dimensions. So what exactly is the slowly changing? Why is it called slowly changing dimensions? In a data warehousing concept, when we split the data into different categories, we split the categories so that we maintain the category of the data in a separate table, which is more or less static. It is not static, but it is more or less static. Like a customer name will change, but it will not change frequently. So, and a product name might change, but it will not change frequently. So that is part of the dimension. So these are the dimensions which are not changing, but it could change. So this is slowly changing dimension. So in our hospital example, if you see, you will have a dimensions for, we discussed that we can have a dimension for hospitals, right? So in that hospital, the address of the hospital might not change every day, but it could change like say in a year's time or in a month's time or maybe in 5 years time, they could change their address location. So this change of the information about the dimension is called slowly changing. So we discussed our fact table and dimension table, right? So we also discussed that dimension table should be easily maintainable, right? So now with this concept, we will see why it is complicated to maintain fact and dimension in the same table. So if we have fact and dimension in the same table and then the data changes, you have to change the whole fact table. You have to change, update everything inside the fact table. We discussed this before. So if a customer name changes and you store the data in your fact table, then you have to change all the records of that customer inside that fact table. But since we are only putting the key of that in our fact table, the key will point back to the same. If the data changes, the key won't change. So the fact table, you wouldn't have to change the fact table. You just have to change the dimension table, create update the record in the dimension table, which will be only one record. This customer could be related to multiple record in your fact table, but you will only change one record in the dimension table. Then it will affect all the fact information when you generate your report. So your report will be consistent. It will show same address for the same customer if you fetch data for this month or for previous month. So your data is consistent even if you change. So that's why I said maintenance. If you split the data into different categories, maintaining the data, organizing the data in a structured way will help you to maintain your data warehouse properly. So coming back to slowly changing dimensions. So I said dimension might not change frequently, but it could change occasionally. So that's why it's called slowly changing dimension. So in this slide, they have given an example. Let's consider an example of a person changing his or her city from city 1 to city 2. It does not happen regularly, right? But it could happen that the person gets transferred from one place to another. He plans to move from one place to another for his new job. So he wants to update his records then to the new address. So that the location dimension, so the person's record might be stored in a fact table, but the dimension for that will be a location dimension where he will change his location. Only the location dimension will change. The person record in the fact table might not change. So it's a similar example to our hospital example. Okay, so how do we actually maintain these slowly changing dimensions? So there are by data warehousing concepts, there are three different types of handling this system. So what I mean by handling this system, handling these dimensions is how much in what way you want to actually update the data in your dimensions. Do you want to keep the historical data, like if I change from city 1 to city 2, do you want to store the data of city 1? When did I change from city 1 to city 2? Do you want to keep that information in your system, or do you want to just keep the current information only of that dimension? Or like how you want to maintain that slowly changing dimension is what is defined in these three methods. First is the type 1 dimension, second is the type 2 slowly changing dimension, third is the type 3 slowly changing dimension. So type 1 is a simple slowly SCD in which you actually override the old value. So you change your data from city 1 to city 2, you just keep city 2. You don't keep your city 1, or neither do you keep when it was changed from city 1 to city 2 or whatever. The next one is, so in the first scenario you are just deleting the old value, so you don't know where he stayed before. In the type 2 you add a new record. So you don't change the key, but you add a new record in your dimension table to change the address from city 1 to city 2, right? So you will always know where he was at a certain point in time and when he actually changed, because you will have all the historical information. And in the fact, you will actually get the data based on your requirement, whether you want to see now, or because you have both the information available in your dimension. So you can do your querying based on how you want to see your report, whether you want to see the current data or the previous data. So you have new record in your table. And type 3 dimension is type 3 SCD is another way in which you actually add a new column. So in this, the first case you just overwrite, second case you add a new record in your dimension table, third is you add a new column in your dimension table. Column as in previous location, current location. So you will have two columns. Your previous location is city 2, city 1, then your current location is city 2. But what if he changes from city 2 to city 3? You will have to add another column, or you will delete the city 1, you put the city 2 there and add the city 1 or city 3 in the current column. So either you keep two columns only, or you add another column for the new data which is coming in. So these are the three different ways. We will see with examples in the later slides. So type 1, update the record, keep only one current record. Second SCD is add a new row. You have historical information, you can keep adding new rows. Third is you add a new column for each incoming, each changing dimension. So let's look into these different types of SCD in the upcoming slides. So let's see first the type 1, override the old value, right? So SCD type 1 is you have one record, and then once James changes the city, it goes to Chicago from New York in year 2004, right? So, but the thing is that you, at this point in time, after the change is done, you would never know where James was in 2000. Say you generate a report, since our data warehouse is a historical system, you will have data from 2000 to 2004, right? But if you have a specific requirement wherein you want to know where this person was in 2000, it will show Chicago, because you don't have the information that he stayed in New York in 2000, not in Chicago. But if your reports doesn't need the information that where he was at that point, then you might not, you don't care. So you just store, you save space and store only one record which is showing you the current information. So that is the advantage, that it is easy and it is saving huge space, because every time everybody so changes, they will have new records as in type 2, then it will consume a lot of space, and there's space there's cost involved. That is the advantage of this system. The disadvantage of this system is no history maintained, which we discussed just now. Okay, so let's look into our next slowly changing dimension, which is slowly changing dimension type 2. In this, as I told, that we will be adding a new record. So you see the ID didn't change, the year changed, the information changed wherever needed, the ID didn't change. The first record in 2000 was 1, the ID was 1, the year was 2000, the name was James, and the city was New York. So James stayed in 2000 in New York, and 2004 he changed to Chicago. So now in our fact tables, when we generate a report, we have a choice to mention the year as a filter to get the location on 2000. But and we can put the year as 2004 and we'll get Chicago. So our report has this flexibility to fetch the correct information based on our requirement. So the advantage is we have history, and the disadvantage is huge space. But huge space is also dependent on the kind of dimension we have. Like in this case, the dimension we have is a location dimension maybe, and say we have only like 300 people in our organization. So it's better to how many people will keep changing their location day in and day out. So the space doesn't really matter in that scenario. So we can have SCD2 and maintain the historical data for that person. So it totally depends on the business scenario, as I said before. So that's about CD2 dimension, type 2 slowly changing dimension. Okay, so yeah, there are few challenges which we have to go through and see what kind of challenges we face in SCD2. It's actually, the concept itself is a bit difficult, and with lot of changes coming in, the concept is for slowly changing dimension, but the real life scenario is not always ideal, right? So we say that okay, this dimension only changes slowly, but what if the dimension changes very fast? So it's very difficult to maintain these dimensions. And how many times do we keep updating these dimensions? Like what is the, so all these process of updation and the query performance and performance tuning, because you will have historical data in your dimension, you will have multiple facts, then while fetching you have to filter it on different things, you will have subqueries. So all these things makes it very complicated to maintain. So yeah, it has historical information, it has an advantage, but it also has disadvantages like query performance. It will be difficult to maintain new records. What if there are multiple updates? Then you will have like thousands of records. Then it is relatively difficult to determine which record is most recent. A subquery has to be written to fetch the most recent record. To overcome these two approaches, to indicate the most current record. Actually, yeah. So if you have there are many ways in which you can access the current record in the dimension, right? So some in some data models you will see they will have dates. Like in this case, they have shown that from start date to end date, and they have shown the status or the expiry date of that particular record. So if you see the first record, it started on January 1st of January 2000, and the end date is like unlimited. So the current record will have end date which cannot be reached, so it is always valid, and that is 31st 12 9999, so which is a random date which is valid till forever. But if you see when there is a new record added, the first record is expired, say, and change the date of expiry to the date when the new record was added, and then you see 31st December 2003 the end date, and the start date is January 1st 2004. So 1st of January 2004 is the start date for the new record, and the end date is forever. So you can see that's how it is maintained to find out which is the current record. So there's another way to find out current record. You just add a current flag. So instead of having two columns, you just won't have the date information in that. You just want current information, then you will have current date and the record date. So in using that, you will have current date column which will tell you which is the current flag which will tell you which record is the current record. The rest will be, say, marked as N. The only current record will be marked as Y, and then you will have a record date on which date this record was entered. Using combination of these two columns, you can achieve the same which is being achieved by having start date and end date. So there are different ways of storing this information to have this two issues resolved. Having a subquery and maintaining the dimension table. So we discussed about another way to do the find out the current record in the dimension. Is the current flag indicator Y and N. You see the first record as marked as Y, and when the second record comes in the type 2 dimension, the first record is expired and the current flag is set to N, and the next flag is set to Y. So this is the way when you generate a report, you access only the current record using the filter Y. Okay, so the third type of dimension is the add new column, right? We discussed first one was to update the record. So type 2 is to add a new row. The third one is to add a new column. So in this, as I told in the previous example, city 1, city 2, where you add a new column and say my old city was New York, my old year is my current city is New York, and my old city is blank when there is first record, only when there is only one first record. And when the dimension changes, you change the city to new city on that particular day, and the old city you will update those two columns, old city and the old year, when actually the old city changed from old to new. So in year 2000, the New York City changed, he changed his location from New York to Chicago. So you will expire that column and add it into these extra columns which you have added. So this is another technique to store the historical data. So but in this case, as I told, you have to keep adding, or you can only keep two, old and the current. In this case, you cannot maintain all the history. You cannot even keep adding new columns for every new city he changes to. So this scenario is used when you don't have to store all the history, as mentioned in this example. So in this example, you just store two previous location, current and the previous, one previous and one current. What else? Disadvantages we discussed. The disadvantages is disadvantage of this approach is that each attribute there must be two columns, extra columns, one indicating the current value and another indicating. So if you, in this case, we are just maintaining city's old and new value, right? What if the person name changes? So you have to add old name and the date when the name changes. Old name, year. So for every column you will have three columns, three extra columns in your table. So any attribute you will have three extra columns. So it's all about space. And also another disadvantage would be that you can only store two values at a time. With this, we have finished the slowly changing dimensions.